Chapter 1 Test Review. For each one of these problems, you're going to want to copy down the problem on your paper, solve it on your own, and then you'll watch me solve it afterwards to see if you got it correct. First one, evaluate if A equals 2, B equals 6, and C equals 4. A squared times 3B minus 2AC divided by C. So I'm going to want to follow PEMDAS for this problem. So I'm going to start with my parentheses, and I've got multiplication and subtraction within my parentheses. So I'm going to do all of my multiplication right away. Now I've got just 18 minus 16 in my parentheses, so I can subtract those and I get 2. So I'm done with the P in PEMDAS. Now I'll go to my exponents. 2 squared is 4. Now I've got just multiplication and division from left to right, so I can multiply. 4 times 2 is 8. 8 divided by 4 is 2. Second one, evaluate if A equals 4, B equals 6, and C equals 2. 8 times 2B divided by B minus C squared. So if I follow PEMDAS again, I'll start off with my parentheses. I've got multiplication, division, and subtraction within my parentheses, but my innermost parenthesis is this one right here, so that's where I'm going to start. So 6 minus 2 is 4. Now within my parentheses, I have just multiplication and division, so I'll work from left to right. So then 12 divided by 4 is 3. So I'm done with all of my parentheses. Now I move to exponents. 3 squared is 9. And then I've just got multiplication. 4 times 9 is 36. Number 3 is a click and drag. Now since this is a video, you guys obviously can't do the click and drag, but I'm going to bring over the ones that go under each property. So remember that the commutative property is moving the numbers or flip-flopping the numbers. So 12 plus 3 equals 3 plus 12, m times n equals n times m, and 5 times 3 equals 3 times 5. The associative property, the numbers stay in the same order, but the parentheses move. Variables stay in the same order, but the parentheses move. Numbers stay in the same order, but the parentheses move. And then for the distributive property, distributing the 2 to the 4 and 7, distributing the 4 to the 5 and 9, distributing the A to the B and C. So make sure you know all 3 properties for the test. Simplify by using the distributive property. So write this one down and solve it on your own. Six times 4 is 24. 6 times negative 9 is negative 54. So 24x minus 54 is your answer. Negative 5x plus 1 times a negative 2. Write this one down and solve it. Distribute the negative 2. Negative 2 times negative 5x is positive 10x. Negative 2 times 1 is negative 2. So 10x minus 2 is your answer. Simplify by combining like terms. So write this one down, 10x plus 2 minus 8x minus 4. Remember, this is where you want to do the underlining. So 10x minus 8x is 2x. 2 minus 4 is a negative 2. 12b squared minus 8b squared plus 6b. Write this one down and simplify. 12b squared minus 8b squared is 4b squared, and then plus 6b. Simplify using the distributive property, and then combine like terms. So write this one down and then simplify. So remember on this one, whenever you see a number outside of a parenthesis, you always distribute first. So 7 times 3x is 21x. 7 times 4 is 28. Now I've got like terms to combine. So my 3x and 21x can be combined, and my 28 will remain by itself. 21x and 3x make 24x, and then I add on the 28 for my answer. 24x plus 28. 2 times 5x minus 3y plus 7y. Write this one down and simplify. Distribute the 2 to the parentheses, so 2 times 5x is 10x. 2 times negative 3y is negative 6y. Then if I do my underlining, negative 6y and 7y can be combined, and 10x stays by itself. I'm going to write the 10x first because x comes before y in the alphabet. Negative 6y and positive 7y make 1y or just y. So 10x plus y is your answer. All right, now we are going to take the relation. Remember, a relation is a set of ordered pairs. So we're given 4 ordered pairs, and we need to make a table, a graph, and a mapping. Go ahead and do those 3 things. 4, 2. 3, 5. 3, 1. Sorry, I went out of order here. Negative 2, 2. So there are your 4 points. Your table should be an XY table. And then I'm going to take those 4 ordered pairs and just place them into the table. Our mapping already has the domain and range labeled for us. And remember, in a mapping, we don't want any numbers to repeat. So I'm going to take all my X values. 3, 4, 3, and negative 2. I'm only going to write the 3 once. So I actually only have 3 numbers I'm writing in the domain. And then 1, 2, 5, 2 for the range. I'm not going to write the 2 twice. I'm just going to write it once. Then I'm going to connect mine to make the ordered pairs. So my first ordered pair is 3 to 1, so I draw an arrow. Second ordered pair is 4, 2, so draw an arrow from 4 to 2. Third ordered pair is 3, 5, so draw an arrow from 3 to 5. Last ordered pair is negative 2, 2, so draw an arrow from negative 2 to 2. Identify the independent and dependent variables in each situation. You don't need to write down the problem for this one. You can just identify the independent and dependent variable. Go ahead and do that now. If I highlight my 2 variables, one of my variables is the number of calories burned. My other variable is the number of pacers. I have to do pacers before I'm going to burn any calories. So my independent variable is the number of pacers I decide to do. And then that will determine the calories I have burned. So calories burned depends on the number of pacers I do. Remember, independent is what comes first, or what happens first, your input. Dependent is what happens second, or what happens as a result of the input, that is your output. The more hours you work, the more money you make. Identify the independent variable and identify the dependent variable. So my two variables are the hours I work and the money I make. Independent, what happens first? Well, I have to work first. And then, as a result, I'll make, the money I make is my dependent. All right, here's another click and drag, so you can just watch as I bring all of these graphs, tables, and mappings and ordered pairs to function or not a function. Now remember, a function means it passes the vertical line test or none of my x values repeat. So I'm going to look for all of the functions right now. So here, none of my x values repeat because none of these have two arrows leaving an x value. This one, the the positive 4 has two arrows leaving it, meaning the 4 repeats, so it's not a function. This one would pass the VLT. It touches once, 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 once. This one does not pass the VLT. It touches twice, so it automatically fails, therefore it's not a function. This one is not a function because the positive 2 has two arrows leaving it. This one is not a function because the 6 repeats. This one is a function. There is one arrow leaving each number. This one is not a function. It would fail the VLT because it touches once and twice. This one is a function. None of the x values repeat. This one is not a function. -5 repeats. This one is a function. It passes the VLT. If I draw my lines through the dots, none of my lines have two dots on it. This one is a function. None of my x values repeat. This one is not a function. The 5 repeats. This one is not a function. This line has two dots on it. And this one is a function. None of my x values repeat. All right, function notation. F of x equals 2x squared and g of x equals 6x minus 1. So you need to evaluate for f of 4, g of -2, f of -3, and g of w plus 3. So solve those 4 right now. Remember, your first step on this one is to distribute. And you have to combine like terms. And one final click and drag. I'm going to plug the f values into the equation. So x squared plus 4, 3 squared would be 9, 9 plus 4 is 13. X plus 2 would be 8 plus 2, which gives me 10. 8 minus x would be 8 minus 1, so that would give me 7. X squared minus 5 would be 5 squared minus 5, which is 20. X plus 8, so it would be -4 plus 8, which is 4. and x squared would be 4 squared, so it's 60. That is the end of the chapter 1 review.